thanks everyone for being here tonight. No, it's a long day, and so appreciate the time you come to hear me talk about blockchain. So I guess I'll just start just a bit about me. So I've been in IT for 20 years, well, over 20 years, but I just decided to stop counting after that. Originally from Canada, in the last 3 years, I decided to move to the UK because I thought it was the old continent was much more interesting than chopping wood. So I'm working in Ursley in Hampshire. I'm part of the Ursley lab of IBM, and I've recently wrote a book on Hyperledger Fabric. Essentially that's going to be the implementation of blockchain I'm going to be talking to you about today. So what are you going to hear about tonight? Essentially, I'm going to take you through three main topics. We're going to start by talking about blockchain in the business. The first disclaimer I would say is I'm not going to make you a great ICO. No, I'm not going to tell you what's the next ICO, what you should be investing on. I'm not going to talk that much about cryptocurrency. I'm going to talk about the underlying technologies, blockchain. So just want to make sure people don't get disappointed. I've listened to him for an hour, never talked about what I wanted to hear. It's going to be about blockchain in the enterprise. Where does it fit? How can we use it? What are the concepts behind it? Then I'll take you through essentially, basically, the mumbo jumbo behind blockchain. So we hear about hash chain, blockchain, we hear about Merkle trees, all these things, but what do they mean? How do we apply them in practice? And then finally, what I'll do is I'll start talking about the Hyperledger Fabric framework, which is essentially the foundation that IBM has decided to invest in for their enterprise blockchain. And finally, I'll show you a small demo of how to get started, because this is, after all, a Java presentation. So I'll show you how to get started writing blockchain application using Java. Sounds like a plan? I would say, if you've got any questions, feel free to interrupt me. Rather, ask the question in context and wait at the end, and I'm trying to figure out what I said at that point in time. So the first thing I would say is, to me, blockchain is all about business network. And I mean, I've been working on a lot of different projects, and oftentimes, it might sound silly, but we often face, customers or people that come with an idea of blockchain of a network of one. Network of one is not a network, and so to me, the power of blockchain is really to facilitate the collaboration across all of us in our different industries and businesses. I would say, business networks are all around us, and what better way to kind of talk about that than to start talking about what I did yesterday. So yesterday was my first day back from vacation. Tough day, so I decided to go buy myself 2 pints of ice cream, as you can see at the top, and some cheap shampoo. Don't need the shampoo, but the point is, how many parties do you think were involved in my small transaction of buying ice cream? Obviously, I was there. I made a payment. There was the merchant. But what are the other parties that were there? You probably could have figured out, there's the credit card company, there's the merchant bank, there's my bank, there's Apple Pay, so on and so forth. So what happens with all that information, and what does that have to do with blockchain, right? You might be asking, where is he going with this? Well, if you start looking at this thing, there's a bit of information that's, we're all going to recognize. And as people working in the industry will kind of recognize that and say, yeah, look, we know what you're talking about. But essentially, there are three main elements that makes up a business network. There are participants, there are assets, where I'm exchanging essentially money for ice cream, and there are transactions. And the thing here to note is the amount of transaction record. And to me, this is just kind of a way to say, we like to work with each other, but we don't really trust each other. So in a sense, what I have here is I've got my identity, I've got the store identity, I've got another identity for the merchant because one is not enough. I've got then essentially an authorization code from the credit card company. I've got a reference. What's that reference? Well, the reference is what's going to make it into my bank account. This is what is going to allow me to reconcile my record to say, yeah, I made that transaction. Then there's a transaction ID to identify the transaction. And then the merchant is also going to have his own transaction ID. Essentially, what happens behind the scene, at the end of the day, once all of this is done, is that there are tons of processes across all of these organizations that are there to essentially reconcile that information. I'm going to go in my bank account. Did they really, well, most of the times I try to do it. I'll go in my bank account, did they really take the eight pounds? Then the merchant at the end of the night, he's going to reconcile all of the transactions that he done. Does that balance? The bank will do the same. The credit card will do the same. Everybody is essentially making sure that everybody else did their job properly. And the reason for that is that we all have a different point of view on the same reality. So all of this is essentially just to show you that for a single, ice cream transaction, all of the things that went behind. And yesterday, as I was preparing this, because obviously if you looked at the date, you'll notice that I bought it yesterday, like I said. My wife said, yeah, look, but what about the guy that's manufacturing the ice cream? How many transactions did he have to go through? And now that's where you start thinking, it's like business network are really all around us, right? And for all of these little point of interactions, we kind of trust each other just enough to do these things, but we don't fully trust each other. So then what we do is we put additional business process around this that essentially create inefficiencies, right? So essentially, that's kind of a way to represent our reality, is that we've got a lot of ledgers. If these are ledgers, we've got tons of ledgers that record those transactions, and then we all do point-to-point reconciliation. So, from the guy that's shipping all the way to the insurer, the regulator, all of these guys are essentially keeping tab on each other. Okay? And to me, this is where I won't say blockchain, because essentially blockchain is just a mean to an end. It's really the power of business network, right? So if we had a business network where we truly trusted each other, or not necessarily trust, and I'll get back to the concept of trust, because that's almost like worth a beer, but the concept of being able to transact without those extra processes of checking each other's out. Essentially, what happened if we had a single ledger across all of these organizations? If we had a single point of view where everybody could go and get a proof and verify that each transaction from a central ledger, what would happen? There would be massive simplification of processes. Now, we can think about that in multiple use cases or multiple industries. If you look at, for example, the supply chain industry, you might have heard about the work that IBM is doing in TradeLens. We're trying to simplify that. All of the paperwork that goes into shipment, all of that, there's essentially a lot of duplication of those processes simply just to make sure that we understand where that data is going. I'll just quickly go back to one thing, though, is that in all of our transactions, there are something that's really key, and that, even in blockchain, we're still faced with, is that we also like our privacy. So the merchant is not going to give me his full number. And my credit card, don't try to put in that credit card with all the stars. It's not going to work, right? So while we want to be able to trust each other and exchange, we still want to maintain a level of privacy. We want to be able to say, well, I'm going to disclose that information for the duration of the transaction, but after that, nobody else needs to know. So when you start putting these pieces together, you can start to see a bit some of the benefits and some of the hype around blockchain and what it can do to the business, aside from the fact that, cryptocurrency and all of that. You can start seeing a bit some of the benefits, but also some of the challenges. How do I start sharing everything, a common ledger, but I hide my private, my bank account information? How does that work? And that's what I'm going to take you through today. So essentially, blockchain builds on the concept of business network. So to me, we can talk about a variety of things, but to me, there are three main elements I've already mentioned. Participants with an identity, so we know who you are, so we know who we're transacting with. We've got to have assets, because essentially, we're not just going to be, I want my ice cream, I want to be able to eat it and feel better at the end of the day. And we're going to have transactions where we're going to exchange goods. So I'm going to exchange some of my hard-earned money in exchange for that ice cream. But we also have implicitly things that are less known of. So we've got contracts that underpin those transactions. We've got an agreement. I saw the price. I agreed to pay that price. The transfer of value happened. And I also got a ledger of log of transactions. So at the end of the month, I can look how much I spent in ice cream. But finally, if you look at those, and it comes back to the comment from my wife, is, you can think of, it's not only a network, it's a network of network. Essentially, it's from the supply chain all the way to the finance, all the way to the merchant, to the final transaction, the end user. And essentially, what blockchain provides in there is the immutable. So essentially, once the transaction is recorded, I cannot change it. It's shared and it's replicated. So everybody gets a near real-time view of those transactions. And that's what we use to essentially rethink some of the existing process. And there are some here, but I'll talk about one. If you think about, for example, account payable. Today, what do we do? If we're in a company, we're going to submit a purchase order to buy a new laptop. That purchase order is going to have to be approved. Once it's approved, it's going to go to a supplier. That supplier is going to then place an order. That order is going to then be shipped. Once the shipping is received, we're going to compare the shipping reception, make sure that the good we order are the real one that we've authorized, and then we're going to issue a payment. All of that because we all have different ledger. But now if I was working from a single ledger, if I had a single entry that everybody were essentially the moment I place my order, the supplier knows about it. The supplier is able to ship it. The shipper is able to come and update the same record, essentially say this specific piece of hardware is now being shipped. It's on this specific car, it's been delivered. And the moment it's delivered and it's confirmed by the shipping, by the reception or the receiving doc, then I essentially update the record, the payment is made. Now, essentially, there are some companies that are actually looking at this project. If you look at Unilever, they've been focusing on how much can they save by optimizing the accounts payable process, simply by bringing everybody on the same ledger, having the same point of view on what is reality. And that goes further, because you can even think about what is the benefit in terms of dispute. If we need to have, if we don't agree on a point of view of reality, typically it'll happen because of two things. Either because somebody made a mistake, or what the other option is that we both have different views on our ledger. I see a transaction, you don't see that transaction. Why aren't you paying me? Well, I don't have that transaction. And then it takes the time to resolve those, right? All that because we essentially have all of those reconciliation process embedded in our business. So essentially, near real-time shared view of the reality, all that with proof of transaction. And now I'm going to flash some interesting number that just say blockchain is really important. I'm going to talk about trust. And to me, I think, because we can say that blockchain is the new era about trust. It's all about, it brings trust into the business. But what is trust? I'm standing here, do you trust me? Do you trust what I say? Would you give me 10 pounds? No, and I'll give it back to you. The question is, trust is relative, and it, philosophers can have a field day with it. But what does it mean? At the end of the day, it's not about trust. Blockchain is about proof of transaction. It's about being able to prove that I was at this point, I signed a transaction, the same way as when, for example, when you go to, you cash in a check, you endorse the check, that the bank was there, that they stamped the check, and they accepted that transaction. And now this fact is recorded and is immutable. That proof of transaction may, not necessarily automatically, engender trust. But trust doesn't happen simply because I got a blockchain and I've got blocks of transactions that cannot change. It happened because they're essentially within a trust framework. We've created proof of transaction that have a business context, a legal context, and finally the technology that underpins it. Okay? Make sense? So yeah, trying to keep track of time. So essentially, so if blockchain is so amazing, so what's behind it? Yeah, sorry, question?
Those projections are great, and you can almost make anyone a consultant. What's the reality today?
What's the reality today?
Yeah.
I would say, you mean
global GDP on blockchain.
GDPR blockchain? So good question. So GDPR pertains primarily to PII, we would say.
Yes, sir. Your GDP, share global GDP on blockchain. You said 10%.
Oh, sorry. Oh, I thought by World Economic Forum. Good question. First, the first thing I'll tell you is I'm not a number guy. I know people like those numbers, and what I'll do is part of these, there's the background links to those. So this is from the World Economic Forum that says that by 2025, 10% of the blockchain, the global GDP will be stored on blockchain.
But,
yeah.
I'm sorry, but at the moment it's zero. There is zero successful blockchain applications yet, except of some retail tracking. That is like almost zero.
At the moment, well, I wouldn't necessarily say zero. So for example, we've been working with the WeTrade consortium. There's a lot of banks, there's 10 or 12 banks now that have joined that consortium that are trading on a regular basis on blockchain in production. We've got the TradeLands project, which is a joint effort with Merkle that is also live. We've got Food Trust. I would say to me, but to your point, we're still very early days into blockchain. And there's a lot, I would say last year, for every 5 use case I saw, there was really one that was truly applicable. There was a lot of things that were good ideas, but not necessarily had the push. And I'll tell you up front, it's not about technology. The problem of solving business networking, making business network more efficient, is not a blockchain problem. It's a human problem. So just, I'll get to you. So I'll say, the challenge is at the end of the day, you still have humans on each side, right? And if you want to get them to agree to transact in different ways, you got to convince them that there is something in them for it. There's an incentive, there's a benefit for it. And to me, oftentimes people come to us with the technology. They get excited by the technology, but they want to overlook the business because the business is the tough part. The governance of a network is a tough part. And how do you decentralize governance and get everybody to agree that we're going to define that little piece that we call smart contract I'm going to cover later on, and that's going to be the rules that we're transacting with. And that's where it gets hard. So I would say today, the reality is not necessarily that the technology is not mature, that it's not stable, but no, I think we've proven, in quite a few times that we can actually make that work. And there are companies that are starting with internal use case and expanding to global, more consortium, because it's easier to get 4 or 5 divisions together agreeing to work with the technology to better understand it than it is to go out with getting a consortium of 25 banks. But yeah.
If you use your example, right, with buying an ice cream, so there are a lot of parties involved, and obviously you can solve the problem by using blockchain, but actually, so what's the problem in the first place? Because you bought an ice cream successfully yesterday, regardless of how many different organizations were involved.
Yeah. So the example around the ice cream to me was just to kind of demonstrate there are business network all around us. Okay, I think to me a lot of those there are still opportunities to optimize, and a lot of those consortium are looking exactly at those problems. Okay, so for example, if you look on the foreign exchange, how do they deal today? How do they work? How do they transact? Getting those trade. How do you net all of those global exchange of billions of dollars? That's another case where we've been working with some companies on that. It's not to your point. We're not necessarily saying tomorrow morning blockchain is going to take over the world, but it's basically an opportunity to kind of allow us to rethink that. So, sorry, you had a question?
One Google request showed me that the today market cap for Bitcoin alone is $96.5 billion.
So.
And then we have Ethereum with $17 billion, Ripple coin with 12.5.
Yeah. So the markets. So the comment, just for the benefit of the other, is that the market cap for Bitcoin is $96 billion, and Ethereum was $17 billion. Yeah, today. And those are just in cryptocurrency. But to the previous point is there are production grade blockchain today out there, and we've got quite a few reference.
Yes. So, but my point is the value of Bitcoin and Ether is only based on speculative investing, and it doesn't relate to a business applications of blockchain. These are two completely different things.
Absolutely, and that was one of the first thing to me. While it's interesting in terms of numbers, and kind of maybe goes and supports some of those numbers. At the end of the day, what I'm talking about here today is the application of blockchain in the business space.
Yes.
Yeah.
So for the business, okay, last point. So for the business application of blockchain, it's even better if the Ethereum goes down in value, because then it's cheaper to run business applications on Ethereum network.
On Ethereum network, but there are alternatives that are not necessarily bound by transaction costs, and I'll cover that. Well, I'll just move on, because obviously we could spend a bit of time, and we can continue the discussion afterwards. But so what I'm going to do is I'm going to spend a bit of time talking about what's behind it. Why why do we care? Why do we get immutability through blockchain? So if you've been a blockchain fan, you might already know all of this, in which case, sorry. But essentially, it starts with the concept of a linked list. I think we're all in IT, so I'm not going to spend too much time. I'll assume everybody knows what a linked list is. One-way hash function, Java hash table. I mean, the idea is a function that you take an input, you generate an output, but from the output, even if you know the formula, you cannot infer what was the input, right? Then you've got hash chains. So essentially, I can take a value, I can hash it, and I can hash the output of that hash, and I can do that multiple times. I can also combine information. So I can essentially now start taking, a value, ABC, calculating the hash, 7859. I can then use that 7859 to add it to another value, DEF, and calculate a new value, 3785. And I can take that value, add it to GHI plus 3785, and I get 5783. That's essentially, we're starting to talk about the foundation of blockchain. So essentially, how is that tamper resistant? Well, if you think about it, if I decided that I'm Eve, and I decided I'm going to eavesdrop and change the value, and now all of a sudden it's not DEF anymore. I'm going to put XYZ. I'm going to get a hash mismatch, right? Because essentially now this value is going to give me 2,957. Doesn't match that value anymore, but essentially detected a change in the hash chain, right? Again, these are essentially very basic, and if you've been there, you'll know that. But that's essentially the concept that makes up blockchain. So far, so good. Now, essentially, if I decide that I'm going to apply that to blockchain, what I'm going to do is I'm going to want to record multiple transactions. Not going to want to record a single transaction per block. What I'm going to do is, to be efficient, I'm going to have a genesis block, which essentially just describes, what's my network. And depending on the implementation, it'll have different information about this. But then I can have essentially transaction 1, transaction 2, the hash of my genesis block, and I can essentially perform the same trick here. So now all of a sudden I can submit multiple transactions to the network. As those blocks get formed, I can calculate the hash, I can increase my hash link, and essentially I keep that immutability across all of those transactions. But what's the problem with this approach? Now, if I've got a block with 150 transactions, if I've got a block with 3 transactions, no problem. I mean, if one gets modified, I'll be able to quickly recalculate, I'll figure out which one's been modified. But blocks of transactions can be much larger than that in production, right? So you can have blocks of hundreds, thousands of transactions. So how do you find out which the culprit if somebody decides that they're going to try to tamper with the data? That's where we bring in the concept of Merkle tree. So I just want to make a pause so far. Want to make sure that A, I'm not putting you to sleep, and B, that everything is clear, makes sense.
Can I ask you a question?
Yep.
So you say so transactions, they
Yep.
go into a block, right, which is an element in a linked list.
Yeah.
How do you determine which block should a transaction go into?
Okay. So the question is, how do you package transactions into blocks? I'm going to cover that. So it's a really good question. So essentially, it's a question of how do we reach a consensus that this is a block to add to the blockchain. I'm going to cover that right after this part. So essentially, the concept of Merkle tree is something that we apply in blockchain from 2 perspectives. A, this is as I'm going to show you, it's a great way to essentially quickly identify within a block which transaction has been tampered with. But it's also a great way to mask information. The concept of Merkle tree is essentially, I'm going to take my transaction data, I'm going to hash it for every transaction, and then what I'm going to do is I'm going to hash the hash of transaction 1, transaction 2, same thing with transaction 3 and 4, and essentially I'm going to hash the root of the whole tree. And essentially, now the idea is that if I have a mismatch, I can quickly identify which branch is the culprit. Because essentially, I can quickly recalculate some of those, move up the chain, and quickly identify where am I getting my mismatch.
Can you explain this slide?
Hey?
Can you explain this slide again, please?
Yeah, sure. So the idea of a Merkle tree is it goes against with the idea that you can hash values. So if I take transaction 1 and I hash it, I'm going to get a value. I can do that with all of my transactions. Then what I can do is I can assemble those transactions into a hashed value. So transaction 1, transaction 2 hashes get added together and then hashed again. And then essentially same thing for transaction 3 and 4, all the way to the root of the transaction. So you can essentially see all your transactions within your block as a tree structure. If you eventually find a block that's essentially contains some transaction that's been tampered with, you can actually use that information to kind of quickly calculate where is the mismatch value. But it has another value in this. Oftentimes, you remember when I showed my famous ice cream purchase, the way my credit card was hidden? Oftentimes, what we'll want to do in blockchain is we'll want to share a transaction. I'll want to share to you that I've got a complete and integral transaction, but I don't want to share everything with you. I might want to share the same data, it's been signed, so I can share it complete with somebody else, and they'll want to see everything. Now, if we've got a transaction field or a transaction data structure that contains multiple of these fields, I can essentially apply the same logic, and instead of putting my transaction data, I can simply hide or mask the data with the hash value of that portion. So by sharing a masked portion of my data structure along with the Merkle tree, now you can almost superpose each one of them, and then you can see that the transaction is still complete, but yet the data is masked. And that's useful in a variety of field, within when you start transacting and you want to, for example, in the supply chain, you can think of, I don't want to share the dangerous good with everybody, but only with a subset of people. So I'll add my complete integral transaction, I'll be hiding the dangerous good. That's one way to see it. Is that clear? Yeah? Cool.
Does this Merkle tree apply when you have, this is like probably very similar when you have a one-to-one relationship on these transactions. When you have a one-to-many relationship, does this really apply or?
Yeah. So essentially the Merkle tree, in the case of blockchain, the Merkle tree is applied to the subset of transactions that get bundled in a block, regardless of their interrelationship. Okay? Because essentially I could decide that transaction 1 is a creation of an asset and transaction 3 is a sell of an asset, but that doesn't necessarily address that portion. It goes back to the question that the gentleman was asking before, is how do you bundle transaction into blocks? Okay? So this essentially precludes, at this point we've already decided these are the transactions that get included into a block. Yeah.
Just going back one slide again, back of the Merkle tree, I didn't understand how you can identify mismatches.
What I'll do is I'll just keep covering. I'll show you in a sec. Okay. So essentially, this is just an application now in terms of the blockchain. So I can now have my same Merkle tree as before, but now what I'm going to do is I'm going to keep essentially my Genesis block plus my Merkle tree, the root of my Merkle tree, and I'm going to have essentially all of my transaction in my block. And I'm going to do that for each block. Essentially, I thought I had the slide for that, so I'll go back and I'll explain. But essentially, it's going to be more, if there is a transaction that's been tampered with, it's going to be more efficient to find it, because I'm going to have only to search a subset of the tree to identify the failed transaction. Okay? And essentially, this is, so if somebody, for example, tampers with this transaction, I'm going to have to calculate transaction of 1, 2, and then this one, right away I'm going to find out that it doesn't match. At that point, I can stop my search. Okay?
These are also blocks, right?
Hey?
These are also blocks.
No, this is essentially, the Merkle tree is a structure that's stored within the block.
Okay.
Okay? Now, few concepts. I said I wasn't going to talk about cryptocurrency. I would say that's probably the only exception here. A lot could be said about the approach, for example, that Bitcoin and Ethereum are taking in terms of spending. There's the unspent transaction output approach. That's essentially kind of was the novel bit that made Bitcoin what it is today. And the idea is that you essentially, instead you've got, tokens are essentially fungible in the context of Bitcoin, meaning that one can be replaced by the other. What you do is you keep a series of transactions that you haven't spent, and then you apply them per transaction. So in this case, I've got 42 units coming in. I'm going to generate 2 transactions, one out that's going to be 40.1 unit. That's going to go into another wallet until it's actually spent. And then out, there's going to be 1.9 unit that's going to be going in different transactions. So essentially, what I do is I take my wallet, I take my history of transaction, and I can actually assemble them as they're unspent, I can actually assemble them to pay for my goods. That's essentially, and there's, obviously I'm pressing for time because I want to make sure I cover everything, but that's essentially the concept. The other one that's often will get used is, for example, if you've got revocation lists. So if for example, if I make a transaction and I say, okay, I'm going to issue you a certificate that says that's valid, and I issue you that certificate. It could be a certificate authority, or it could be just a certificate. I signed. This is some goods I'm going to sell to you in 5 days. And I decide to revoke that. Well, typically what we'll do is we'll be looking at revocation lists, and we'll publish those revocation lists so that every member of the network has a single view of what's allowed or not. But that information often, we don't want it to be de-encrypted. We don't want it. So what we'll do is we'll encrypt that list, and we won't want to let anybody know what's inside of it. Crypto accumulators are a great tool for that purpose. And while they're a lot more complex than what I'm showing here, what you can think of, and it always goes back to prime numbers. If you take a bunch of prime numbers, if I take 3, 5, 7, 11, if my calculations are right, and I multiply them all together, it amounts to 1,155, right? So from that point on, if I kind of delete that list from the top, and I just say my crypto accumulator at this point is 1,011.55. It's great. Now, is 3 in the list? Well, it's easy to validate if 3 is in the list, right? Can I divide that number by 3? Because they're a prime number, it's either going to come back with a full number or not. So in this case, if I test is 13 in the list, come back with an incomplete number. So essentially, with that little trick, I can start accumulating those transaction ID. I can merge them into a crypto accumulator, and I can now test the validity of a claim. So I can make that claim, I can sign it, I can add it to the crypto accumulator. It's part of the valid list. If I decide that I'm going to revoke it, I simply update the crypto accumulator, and now it's not part of that list. So you can see the application. Behind it, obviously, it's slightly more complex than that. But the idea is that through zero knowledge proof, you don't get any insight in terms of what's part of that list. You're able to verify whether a claim is valid or not. So again, the idea is that here in this case, what I wanted to do is share with you some of the concepts behind blockchain, some of the idea of how this gets applied both to support the blockchain chain of transactions, but also how this can apply into business application in terms of maintaining some of those information and maintaining some of the privacy. There's a lot more to it, but so some of those are the concept. But the question is, how do you get those transactions in the block? So I kind of explained to you, I kind of walked you through, all the way to the block. But to your point is like, how do you make sure that a transaction is valid, and how do you add that to the block? Because essentially, I can create that blockchain with loads of invalid transactions that don't meet the business rules of our network. And essentially, that's where what we call consensus comes in. In the case of Bitcoin, you'll hear about proof of work, and you'll hear about miners, and you'll hear about the fact that essentially that as transactions get disseminated across the network, miners grab them and try to assemble blocks and validate all of those transactions, trying to solve a complex cryptographic puzzle in search of essentially the transaction fee that they can claim for their own transaction or for their own benefit, right? So that's the whole reason behind Bitcoin, why those Bitcoin farms, that's how they work. But there are other consensus that have been created out of the industry. You might have heard about proof of elapsed time or proof of stake. So the idea is that proof of stake, if you've got some vested interest into the network, you'll want to maintain your own credibility. Elapsed time is a different version. The one that I'm going to essentially talk to you about tonight is the one that Hyperledger Fabric use, and it's the concept of endorsement. Concept of endorsement is really, really close to the business reality, and to me that's why I think it's interesting, because essentially part of our reality, whenever we go to the bank or things like that, the example of the check before, we always endorse those transactions. When I tap my wrist, to make a transaction to Apple Pay, or I put my card, I'm endorsing a transaction. The merchant is also endorsing a transaction, when he push on the cash register. The reality is all of those transactions are essentially more or less endorsed once a contract has been fulfilled, right? So essentially that's where you start getting into, well, what is the smart contract? What is the logic that we're going to make sure that we can validate that a transaction is valid? Once we know that the transaction is valid, then how are we going to bundle it into the block? And that goes back to the consensus that I just spoke about. So does that answer the question? Cool. So essentially, blockchain for business, I would say, is all about these 3 points below. So it's identity over anonymity. It's a selective endorsement. It's essentially the ability to have businesses endorse transactions and agree that they should be part of the blockchain through the execution of a smart contract that's been pre-agreed on. It's the concept of asset over cryptocurrency. And I would say, to me, blockchain is still very early on. We've been working on this since 2015. There's still quite a bit of work being done. And so the idea of how do you bring together assets and tokens and start representing some of the real exchange that we have in our day-to-day are still being formed. And I'll talk to, obviously I've been working particularly with Hyperledger Fabric, so I'll talk to you about what we're doing in that field. But that's essentially what we're talking about. So, any question? Yeah.
Yeah. So for the proof of endorsement.
Yeah.
What's the benefit? I mean, who gives that endorsement?
It's a really good question, and this time I'm not lying. So the question is, in the concept of endorsement, who gives that endorsement? And this time I really have a slide for that one. So I'll answer that in a few seconds. So now essentially that next section is we're going to be diving into Hyperledger Fabric. So I'll take you through. It's a bit more on the technical side. We're going to be probably back to things that we know, but I'll start showing you what it is. Essentially, in Hyperledger,
You mentioned about the proof of endorsement for Hyperledger. What mechanism does Bitcoin use?
Proof of work. Proof of work. And proof of work is what essentially the idea of that you disseminate transactions, miner get transactions, and it's a race to.
Broadly, there's some similarities in proof of work and proof of.
I would say, well, aside from the fact that they result in a block being added to a blockchain, completely different. Proof of work is very highly computationally intensive. It's costly in terms of energy and all of that. Endorsement, I would say, is low on cost, but it requires parties of people of organizations that know each other.
But proof of endorsement would still be dependent on somebody having to say, complete the proof of work aspect.
No. I'll show you how it's actually happened. but we don't have any. So part of Hyperledger Fabric, if you're planning on becoming an Hyperledger Fabric miner, you're not going to make any money. That's the unfortunate reality. There's no such thing. So part of our essentially part of Hyperledger Fabric, you can look at it from the perspective that there's peers. Peers are nodes that hold a ledger. Ledger is what? It's our blockchain transaction. So our series of blocks that contain those transactions are immutable. But also what we do is we have a state. What is a state? Well, if we start transacting together, and I say, we're in the car industry, and I start manufacturing a car, and I create a transaction that now instantiate a virtual car part of our network, then the car is going to have some characteristics, right? And what I'm going to want to do is I'm going to create a transaction, submit that transaction, and say, now there is a car. It's been endorsed by Luc. So the question is, obviously it goes back to what I was mentioning before, trust framework. What is the business, legal, and technical, right? So we need to agree that from a business perspective, Luc can create cars. And we need to agree on what are the rules to create a car. But let's assume that this has gone through. Now what we want to do is we want to persist that information into a database, into a world state, okay? And I'll be talking a lot about the world state. As endorsing peers, essentially an endorsing peer is a peer that will sign transaction. So it's not only adding blocks to its ledger and updating the world state, but it's also running the smart contract. So it's the one that essentially runs the smart contract, receives the result, makes sure that the smart contract completes successfully, and then stamps the transaction with the identity of the organization. And finally, we've got ordering nodes. And ordering nodes are essentially what is different from what you would expect to see in a Bitcoin type of transaction. So ordering nodes are play a specific role in our network in that they accumulate transactions. They are listing on the network, they receive the transactions, they bundle those transactions, verify that signatures have been applied, and then they send the transactions to the peers, and the peers will essentially commit those transactions and then send an event back. Okay? So if I kind of look, from a 10,000 view in what is Hyperledger Fabric, that's essentially what it is we've got a membership service. What is a membership service? Well, I mentioned before, that it's all about identity. So one of the things that's really different from the unpermissioned network is that every member of the business network have an identity, and everybody will be able to know if I submit a transaction that it's Luc that signed that transaction. So it's not just, wallet address A, B, C, D, E, F. There's a real identity that's tied to it. So the membership service is essentially the one that issues identity and the one that ties back that identity to a specific organization. We've got peers, which I mentioned can be either endorser or committer, that are going to be maintaining the ledger on our network. They maintain the ledger. They run what's called chain code. Chain code because sometimes we want to have different naming. So instead of calling it smart contract, it's called chain code. But essentially, it's the business logic that gets executed when a transaction gets submitted. And at the end, essentially, it can emit events. So why emit events? Well, we'll see in a few seconds. Essentially, what it allows us to do is allows us to notify our client that transaction has been committed. Because essentially, a blockchain network is a major asynchronous network, right? Not everything happens synchronously. So you send an event, you wait for the blocks to be formed, to be sent out, to be disseminated across the network, and then you listen to make sure that your transaction has been accepted. So you've got the membership that provides the identity for each of the organizations. So each of the components on the network have an identity. You've got the peer that maintains your ledger. You've got your ordering service. That is the one that receives block and publishes block. And you've got essentially your client, which is going to have your client identity, a wallet, and it's going to be making calls through the SDK. Okay, so far so good. Essentially, from that perspective, we get exactly the same concept of blocks as we had before, except that now, not only, because what we say oftentimes is that Hyperledger Fabric is a permissioned network, What we mean by permission is that all of the policies of the network are also embedded to transactions that are submitted on the blockchain. So essentially, we start by a configuration block that says, who are the participants of our network? Because it's not simply because I've got a membership service, I've got a certificate authority, I've got a certificate that I'm automatically part of a network. I need to be invited to that network. And now, if we're all going to be decided, if we're all going to have peers on Hyperledger Fabric, we need to decide what's going to be the rules. Can anybody invite anybody? Or do we need the majority of the group to say yes? Or just me because I'm setting up, I get to make the decision? And that's where I would say that goes back to the governance. Like, as a business network, how do we want to work together, right? Well, the idea is that all of these transactions are stored in configuration block. I'm also going to have transaction blocks, which are really my business transaction, what it means. But all of that essentially gets applied to the world state. And the idea is that essentially, when we're executing a smart contract, we're taking a series of input, we're looking up values in the world state. So, for example, if I want to sell my car to you, the smart contract would say, well, does the car belong to Luc? If the car doesn't belong to Luc, end of it, the transaction won't complete, right? Well, how does the smart contract figure that out? It goes against the world state, it pulls out the car record, it looks up, who's the owner, Luc is the owner, and essentially then it produces a transaction read-write set. So essentially, you read these keys, this is the key you read that you read the car, and the car had the ownership of Luc, and then you wrote that the new ownership is your name, which, and essentially that smart contract essentially decides what gets written on the ledger. So when we're writing a Hyperledger Fabric solution, we're essentially writing two main components: the smart contract that decides how we're going to collaborate together, and our client application, which essentially triggers those transactions. Okay.
Just a quick question. What's the reason to choose those two databases? And can we use a different one? How difficult it would be to integrate it?
That's so just for the benefit of the question is, why those two databases, LevelDB and CouchDB? So the idea, and so I'll answer, and so the question is, why those two databases, and can we use others? So the idea of Hyperledger Fabric is that it's the concept is that it should be pluggable. Okay, so the idea is that you could eventually plug in a world state. They started with the LevelDB because simply from a blockchain perspective, the nodes tend to be self-contained, and LevelDB was a great tool from that perspective because it's very self-contained. It runs within the same memory space as a peer, whereas CouchDB runs as a separate instance. I wasn't necessarily privy to the decision of LevelDB, CouchDB, but one of the things I know is that they're looking at essentially expanding the offering to allow you to pick different databases. But today, those are the ones that you get to choose. Okay, and essentially, I would say, the idea is that document store database. So this is again, the idea is that it's a ledger of transactions of assets. You track those assets, but they're not. One of the things that I would say is that blockchain is not about trying to replace relational database. And that's another pitfall that I've seen often, because people think, oh, great, I've got a replicated database. I'm just going to apply my analytics to it and then see it crash and burn, because essentially that's really not what it's meant for. There are patterns for that. Yep.
So just understand, CouchDB is not part of the Hyperledger. It's not part of the blockchain. It sits elsewhere. That's where the information, document, ID, everything is stored.
Yep.
LevelDB is where the key is stored, and that's effectively what is hashed on the blockchain.
So there, I would say it's almost correct. So there are essentially two conceptual components within Hyperledger Fabric. There's the ledger and the world state. You are correct. The ledger is stored within LevelDB, but essentially it's just a series of entries. So it's an append-only database. And then you've got CouchDB, which is, and that ledger is immutable. You cannot change it. The world state is mutable based on the content of your ledger, which is stored in LevelDB. So you got the two. CouchDB you're correct, it's a different open source that we've kind of brought in to support the concept of world state within Hyperledger Fabric. And it's running right now, all of these solutions are running as Docker containers. So essentially, whenever you've got an organization that deploys a blockchain Hyperledger Fabric node, they'll have the peer and they'll have the CouchDB, oftentimes like co-located for performance reason. But yeah, okay. Just doing a quick time check, 6:30. So yep.
So the ledger is not in a database.
The ledger is not, so the ledger is in Level DB, which is a database that's within the peer node. Yep.
So the ledger is always in Level DB, but the world state can be in Level DB or CouchDB.
That is correct.
Thank you.
Yeah, and the main difference between the two is the idea that CouchDB provides you structured queries, whereas Level DB is a bit more basic in terms of queries. A quick time check, and it's 7:20, so time flies. I've got a quick demo plus a few slides that I might try to pick up. But like I said, happy to take more questions. So essentially, what's different from other transactions is that normally what you would have is you would have essentially the validate. So you would have the execution and then the order in the case of Bitcoin. So what you would do is you would execute a transaction, it would get ordered, and that would be the end of it. So what we do in the case of Hyperledger Fabric is we run an endorsement phase, which essentially is running the smart contract, which generates that set of read-write key values that gets sent for ordering, gets disseminated across the network, and get validated by the peer. Essentially, doing it that way allows us to catch any type of double spending. So, because essentially when you go to the validate, what we'll do is we'll compare the value that we originally read with the current value of the world state. So if somebody tried to tamper or if there's differences, those transactions will get rejected. I'll show you quickly what it looks like. But so essentially now imagine we've got 3 different organizations. Okay, so I've got org 1, org 2, org 3. I've got my client application sitting here. Org 1 has 3 peers. Okay, so for resiliency, maybe this application is more important to org 1 than org 3. It has 3 peers, one that's going to be endorsing, and has 2 smart contracts, AB, AB, and AB. It has 2 peers that have maybe different set of smart contracts, but they're all share the same ledger. Now, what we're going to have here is essentially what we talk about endorsement policy. It goes back again to the idea that the network is permission. So essentially, when I'm deploying my smart contract, I need to tell the network who needs to sign. What are the minimum requirements in terms of endorsement? That's going to go essentially against all of the organizations that are part of the policy and ask for an endorsement. P3, P4 are not part of the policy, but anyway, what we are looking for is signature essentially from the organization. While it's a peer that's signing, really what we care about is the organization that signs. And here I've got my ordering notes. So essentially what I'm going to do is I'm going to send a transaction proposal to each of those nodes. I'm going to send a transaction endorsement to node 0, 1, 2, and that transaction is going to then execute. The smart contract is going to get run into the container A and B, which is essentially my smart contract. It's going to return a result to my transaction. And that's where the idea is that each of these organizations maintain their world state. If, let's say, I want to pretend that I'm rich and all of a sudden I create a car and it hasn't gone through everybody else, they're not going to have the car. They're not going to have the same view. They're not going to see the same world state or the same ledger. So what's going to be returned to the client is essentially potentially 2 to 3 different answers. For the blockchain to accept a transaction, this is where the endorsement comes in. Everybody has to sign the same result. So if there are essentially three answers and they're not matched, the transaction is going to get rejected. Ideally, the client is smart enough to say, hold on a minute, somebody's coming back with a different answer, reject. Or it's going to go all the way to validation, and in which case the peers are all going to realize that there's an answer that's mismatched. Now, obviously, the next question is going to be, well, what do we do about this? But because we're working with organizations that know about each other, that's where essentially, an organization could essentially step in and either check if they've been hacked. Is it a question that they were down, they're missing a block of transaction? But that's essentially what's happening there. So essentially, once the application receives all 3 transactions back, the transactions that have been signed by each organization, that essentially fulfills the endorsement policy that said all 3 orgs had to sign. The application is going to send that to the orderer. The orderer is getting transactions from across the network, right? It's not necessarily only from this client SDK. So you can imagine it's receiving all those transactions, ordering them, maintaining the order in which it's been received, and then it's going to cut blocks according to configuration on the network. The orderer then disseminate the blocks to each of the peers. You may notice here, peer 3 and 4 are not endorsing, but they're still committing. They're still interested in what's happening in the network. They're just not stamping the transactions. So they're all going to get the transaction back. Well, it's actually the block of transaction, and it's then going to go and validate those block of transactions against the world state and make sure that the read set that was part of the transaction is still the same read set, and then going to apply the write. Once this is done, they're going to check that all of these transactions are committed. So they're essentially going to mark on the ledger, yeah, that transaction was valid. And they're going to send back a notification to the client. Now the question is, from a client perspective, you have the decision. Like, am I going to wait for the whole network to come back to me and say, yeah, you all said yes? Or are you just going to wait for your own organization? Now it becomes a question of, what are your business rules? You might just be happy enough to know that you've got a block that was committed and was accepted by your own peers, and you're happy enough. Or you might want to wait from all of the organization. Okay? That's essentially, in a very rapid fashion, the idea of how blockchain works in the world of Hyperledger Fabric. This is how we go from a consensus of endorsement by having organizations sign those transactions according to business rules, and then having the ordering node distribute those blocks across the network. So essentially now, where does Java fit in there? I took the gold vault because that's where the money is. So what I'm going to do now, so we're really might overrun by a few minutes, but I'm just going to essentially walk you through where Java fits in. Essentially, like I've mentioned, there are 2 major places where we're going to be working on for our solution. There's the client application side, the JDK, the client application, which runs the Hyperledger Fabric Java SDK, runs your wallet, keeps your identity, and then signs transactions. You've got the smart contract that's running on the network, which we called previously chain code. And that chain code is essentially what's going to result in putting new keys on the ledger or altering keys, and results in transaction being submitted. All of this, like I've mentioned, as the concept of events. We've got events are system level. So essentially, block has been committed, new transaction has been accepted, and there's essentially business level events that we support. The scenario, and good thing I kept it short, is a very simple one. So I could have gone, with full-fledged business use case, but I decided this is a technical audience. I decided to keep it more on the simple side. So what we're going to have is essentially a client that creates a car and then can query a car. I'm going to have a smart contract that's going to run the car creation, and I'm going to also have a listener that gets notified of new transactions being received. Okay, all of that is running on a VS Code platform. So where essentially IBM's been contributing significantly on the Hyperledger Fabric, but we're also providing a plugin and extension to essentially facilitate the development of smart contracts, whether Java, Go, Lang, or Node.js, and then essentially facilitates the deployment into a network. So you can get essentially your own little network spun up quickly, you can run tests, and deploy that. And finally, obviously, this is an IBM presentation, so we do have a SaaS platform to run enterprise network. So you can get started with our version 2.0. The nice thing is that it's deployable across. It's really fully decentralized in the sense that you can run that on our IBM Cloud, on AWS, Azure, on your on-prem. You've got the choice is yours. So with that said, what I'll do is I'll quickly show you what it looks like. And then I can take some question. Just going to make sure that I'm connected. And this time I'll be able to zoom in. So it should be. So essentially, I've got, in my workspace, I've got 3 projects. I've got my Java client, I've got my listener, and I've got my smart contract. A smart contract will look something like, now obviously because I've zoomed. A smart contract essentially just extend that base class. Thing I'll say up front is that there's a lot of work right now being done within the community to include advanced capabilities, like for example using Spring and things like that. So the code that you're going to see here may not be necessarily the most, the latest and greatest. But essentially we've got 2 main functions within the chain code. You've got the init function, which you can think of, when you're deploying your chain code, if you want to preload some reference data into your world state, that's a place to do that, because as your transaction, as your smart contract gets instantiated into the network, that data gets loaded. And you've got a function that's called invoke, which you'll get from that essentially a function and a series of parameters that you see here at the top. And essentially, I've got a few functions. I can init the ledger, I can query car, create car, I can change the car owner. And essentially, if I look at, for example, Luc creating a car, you're going to see some of the things that I've mentioned. So it might sound a bit more familiar. So essentially, what it consists of is I created that car. I converted that car into a JSON payload. I've put the state. So essentially now what I do is I take the key. So what's going to be, that could be the license plate of the car. It could be a car registration. I use that as a key, and I'm going to put the car as a byte that's going to go onto the ledger. I'm also going to emit an event. I'm going to say there's a new car event, and then I'm going to publish that information. Now, obviously, this is a very basic smart contract. I haven't performed any validation. I took all the information as face value. But that kind of gives you a sense. And the idea of emitting events, that means that now all of a sudden, I could have, for example, an insurance company that's listening for that new car event. Now, and that's where some of those ideas come true, right? If I got that business network and I'm starting to bring some different business organization, different industries, I can start thinking of some of those things. I'm just going to return that the transaction has been a success. I can also run some queries. I can say essentially what are the queries, what are the key value, and I can emit that in terms of an array that I'm returning to my client. On the client side, if I look in terms of what does it take to invoke a transaction, you're going to see the similar type of process that I've mentioned before. So essentially, I'm going to start by getting my wallet, pulling out my identity, then creating my connection to the network, submitting a transaction proposal, validating that I've received all of the response. So that's what you see here, proposal response. I'm getting the status, make sure that the transaction was successful. And I'm going to send the transaction back to the network. And that's essentially going to go to the orderer and get disseminated to each of the peer of the network. Finally, if I wanted to, the last part that I wanted to show is the listener. Listener is going to go through similar type of processes. It's going to go through registering, pulling out the identity from the wallet. But now instead what it's going to be doing is going to be registering for chain code event listener. So it's got now what it's going to do is going to say, I want to listen to a specific transaction. So you can either listen to a block. You can say, I want to know whenever a new block comes in. Or you can say, I want to know where a specific business event happened, and I want to be notified of this. There are essentially other things that you'll see here, and you'll get a link to the repository, but essentially You can enroll your identity, you can register your user, put your user into your wallet. That's like more like basic housekeeping that we do to manage identity. So far, so good? Yep. Okay. So what I'm going to do, well, I'm going to zoom out a bit here. I'm going to first thing I'm going to do is I'm going to start listening on the network. And what the moment you subscribe to the network, what I've done, let me kind of zoom that in. That's a challenge with demos of like that. So what you see here is essentially, I've just started listening to events. I've received a block. So whenever you sign up, whenever you register for for block events, you'll always get the last block. So essentially, I've got event 2. So it means that I've got 2 blocks on my blockchain at this moment. And my peer 0 from my org 1 has been sending me that block. And that's the identity, the membership service provider. That's the identity of the transaction. I'm going to come here and essentially, oh yeah, sorry. I'm just going to run the transaction invoke. So if I go back quickly to my invoke, what my invoke was doing is essentially sending a request to create a car, which was an Honda Accord Black and belongs to Tom. So if I go here, I press enter, my transaction is going to get submitted. And essentially here, what happens behind the scene is what you see is I've received a block, a third block, which contains a single transaction. Obviously, it's a test network. It's been issued by the organization 1, and it's essentially that transaction that belongs to Tom. Very basic in terms of use case, but it just kind of goes to show a bit, the simplicity in terms of getting started with some of those samples. All of this is running locally within my VS Code extension. So I've got that network running locally. I can deploy that smart contract to it, and I can actually invoke some transactions. In a real-life system, blocks wouldn't be published with a single transaction. Typically what we see is we see blocks of 150, 300 transactions, depending on the business scenario. So that's really what I had to cover. Any question, I guess, on the short demo? Yep.
So why is the endorsement verification happening with the client? Why is not, because then your application can basically decide how you deal with the endorsements as opposed to keeping it centrally within the
So the good question. So the question is, why is the client dealing with endorsement? So the only reason that the client looks at the response and deal with endorsement is purely from an effectiveness perspective. So if the client decided, I'm getting all these response, blind eyes, I'm throwing that to the orderer, it would fail at the validation. So the network would look at the policy, would say, okay, this is a smart contract. This is the policy I said I was going to respect. It's not respected, reject the transaction. It's just that, obviously you've wasted quite a bit of resources just to get there. So typically, just from a pure efficiency perspective, we'll have the client validate that you received the right response so he can react faster to the end user. But the real policy enforcement happens at the network, doesn't happen at the client. Okay. Yep.
Just to check that I understand that, does that mean that actually in a fully running production network, the client might not actually be able to do those checks efficiently, because if the rules for doing the checks are stored on the blockchain, they might change over time, right? So,
they might change over time.
Actually, in order to do those checks in the client would have to query the blockchain state to say what are the current rules before it could check, in which case it becomes easier to just throw it to the ordering service and go, do your thing.
That's a very,
duplicating behavior.
That's a very valid point. Although the thing I would say is that depending on the approach that you take for endorsement, because now there's various ways, you can have a static type of endorsement policy, in which case you know it's always
sure.
that,
You're not changing.
or you can have a state-based, so you can say, well, depending, if it's an asset that's been created by Ford, then Ford endorse. If it's created by Honda, then Honda endorse. In which case, then yeah, you're quite right. That policy could become so convoluted that the client just essentially throws it back at the network. So it's a case of it depends, but there are now, one of the things we've been doing is essentially things around service discovery, so that your client can easily discover, what are those rules that he needs to enforce before he sends. So, yeah, question?
Very fundamental question. So as you mentioned, the transaction is hashed in the block. So how can you restore the original information to display in your console?
So within, obviously, one of the things I could do is in that log of event here, once I've got the block event, I could show you, there's the API to essentially retrieve the hash of the block, the hash of each of the transaction. So you could essentially just emit those as you go, but they're essentially maintained at each of the blocks. So you've got those. So when you connect to the network and you're entitled to retrieve the blocks, you can actually retrieve and validate and verify. Is that so? Did I answer the question?
Yes. So where's the code? At what point of time are you doing the encryption in terms of your job system?
At what point of time? Okay. So I think I know your question. So essentially, the idea is that Hyperledger Fabric does some of the work for you on your behalf. So when I create that, let me kind of just zoom in. So essentially, from an Hyperledger Fabric perspective, the only thing you'll know is that you've got a wallet that contains an identity. That identity has a certificate, and then once you essentially loaded that identity, all of your transaction proposals are going to be signed using that identity. So when I go here and I essentially set my crypto suit and I essentially set my wallet to user 1 and I set that user context, all of my transactions are going to get signed from a client perspective using that identity. When I send my transaction proposal within the block, and if you're interested, I can pull out the block structure and show you after. But essentially, within the block, what you'll do is you'll see for each transaction, you'll see the input parameters, the signature of the client, and then followed by the signature of each of the endorsers, and that's per transaction. Now, the framework itself doesn't, you cannot get access. There's API for each of these things to get exposed to that, but the framework behind the scene takes care of all of that for you. Okay, thank you. Any other question? Yep.
When does the Fabric agree that an event has occurred? Because you had smart contracts issuing events, but those smart contracts will be run multiple times, right? By multiple nodes potentially. So we'll have multiple instances of those events being issued by each of those runs. Somewhere. But really, we only want to see one happening,
exactly.
Because it's logically only one event. So when does the network agree that an event has actually happened?
So essentially, when you send for endorsement, it's a client that's sending to the multiple endorsers. It's packaging all those results and sending it to the orderer. At that point, all of those endorsements are packaged as a single transaction, so that the network has always maintained the proof that all 3 endorsers replied the same response at that point in time. So that transaction then that contains 3 responses effectively gets then carried across the network as a single transaction within a block of transaction, and that's that block that gets disseminated across all of the.
And that's the point when that event that was triggered by the smart contract will actually happen.
Exactly. Yes.
So it's a convenience that you can code it in the smart contract, but actually, in terms of anybody who listens to that particular event being notified. That actually only happens
Happens
once,
on the
once
commit.
the network has agreed that the transaction is
Exactly, because that's where the event really, and that's why what you see here in terms of the API call is not like launch event or throw event. It's just set event, because essentially at that point the event has not really occurred.
Mm.
And, yeah. Yep.
How does a blockchain deal with hash collisions?
Sorry. How does block
Blockchain deal with hash collisions?
with hash collision? So essentially, well, I guess just kind of so hash collision within the blockchain itself. Typically, the algorithm is wide enough. So there's, like you pointed out, there's always a possibility of hash collision, but the algorithm, the cryptographic algorithm around those hash, the possibility of collision is very infinite. So in terms of statistics, it's like, I think you stand better chance of winning a lottery than getting that collision. Any other question? Well, it's been a pleasure to present. Just gonna, obviously, I'm part of the IBM Blockchain Lab, so we do obviously work on a regular basis on projects like this. I'll just leave you with that. Typically that's our journey that we see with customer. And I would say very much last year, we're very much on the discovery, spending quite a bit of time with first project. Now a lot of work these days is focused a lot more on pilot and production. So we're essentially helping customers through their journey. So if ever you see a good blockchain use case, you can, we happily work with customers to do a discovery workshop for a few days, no charge. But if you want to take us for the journey, we'd be happy. I hope that the presentation has been helpful for you guys. If you got any question, I'll stick around. And yeah, thank you for having me.